Hello friends, today's video is about learning exploratory data analysis with the employee dataset. Okay, so let's understand what is exploratory data analysis. So exploratory data analysis, which is called EDA, it's an approach where you have to analyze the data before we perform any sort of experiment on the data. So for any project in machine learning or AI, it's very important that we understand the data in detail, because for any projects, data is the most important thing. Okay, this finding a solution is the last bit of the work, but understanding the problem and data, it holds the key. Okay, so EDA helps in examining the data sets into understanding their main characteristics, defining patterns, understanding the patterns. We try to detect the anomalies like outliers, understanding if there's any missing data, and assuming and generating some assumptions based on the data. This is where EDA comes into picture. It also helps us to understand relationships between different features and columns or variables. So that is why EDA is important. Now for this video, we'll use employee data set to understand how actually EDA works. Okay, so let's get started. I'll open up Visual Studio Code, and here for this video I have picked up a dummy data set of 100 records of employee. Okay, so let's see. So first step is we'll import all the libraries. Okay, then read the CSV data into pandas library. Okay, so if you see, there are total 100 records and I have three columns, or you can say three features: age, salary and department. Now let's assume there is a problem or use case where we want to predict salary based on age and department. So for that I want to understand a what are the uh, you know what does the data, age and department and salary contain. So let's get started. So first step, so here I'm dealing with only three columns, but in reality you may deal with say more than 100 features or 100 columns. So it's important for you to understand which are the data types. So here for age I'm using here I'm seeing for age it is float, salary is float, department is a string. It shows me a string. So string means it can be a categorical variable or it can be a text variable, but in this case it's a categorical variable. Okay, so let's click on data.describe because it's a Python data frame. So .describe will help to understand what is the basic statistics. So let's understand the statistics. So if you see, we have age and salary, and when you do a describe, it will only generate statistics for numerical columns. Okay, so like here we see total only 90 values are there out of 100. That means there are 10 missing values here. Okay, what is the average age is 39.9 and average salary is 76,172. And what is the minimum age is 22, minimum salary is 30,206, like this. Okay, now for EDA it is also important for us to understand how many missing values do we have. Okay, so I'll just run this. So I see for age there are 10 missing values, for salary there is 8, and for department there are 6. Okay, so here we'll deal with how to fix the missing values later on. First of all, we need to understand what does age and department and salary data say to us. Data talks to us. So one way to perform analysis, exploratory data analysis, first we'll try to do a frequency distribution of age. This is called univariate analysis. So here I've selected bin of 18. That means it will create 18 bars here. And if you see in when I generated the histogram, Here it is showing on the y-axis is the age and x-axis is the count. Okay, so if you see the age between 25 and 30, here this is the highest bar with the um, 9 employees, which are between 25. It's more than 9, but for say around 30 age is there are around 9 employees. Then for 35 age there somewhere around 8 employees. For 45 it is more than, it is also same like 9 employees. So this is what we see. So there are employees with majorly where age is around 30, 35, 45. So if you see the employee count is more. Okay, so similarly let's do it for salary. So for salary I see here, if you see the salary distribution, there are bins at 20. That means 20 bars are here. And here if you see the highest salary is, if you see here 50, around 50,000, 60,000, 50,000 salary is 10 employees hold salary around 60,000. Then uh, 9 employees hold salary around uh, around, you can say, 80,000. And 1,20,000, you can say around 8 employees. So this is the way salary distribution is looking. Okay, now let's check on the department. Now since department is a categorical column, okay, so we need to see the count of department employees per department. So if you see, count means employees per department. So our data set is having 100 employees data, and every employee is associated with one department, has an age and has some salary. So here we are seeing number of employees per department. So I see IT department has the least number of employees compared to HR has the highest number of employees. Then the second is finance, third is marketing, fourth is sales, and fifth is IT. So see, IT is having a lesser number of employees. Then let's try to compare age versus salary. We need to see, is there any relation or any information available where we try to compare age versus salary. So here I have used a scatter plot just to see, are there any data points coming together for any specific combination. But looking at this data, I don't see any relationship happening here, because all the data points are like very much scattered, they are not together. Okay, so we can't say anything out here, we can't infer anything out here. Okay, now if you want to see more, if you want to perform more analysis on the department wise, then you have to filter the data based on the department. Okay, so we can also select your data which is only for say HR department, because HR department is having highest number of employees. Okay, then we'll try to run the box plot where this is called bivariate analysis, where I'm trying to compare age versus salary, and here I will try to compare department versus salary. Okay, so per department, what is the salary distribution per department? So here I'm using a box plot. So in this box plot, if you want to understand how the box plot works, is this horizontal line, if you see here, that is the median salary. Okay, so if you see, the HR has a highest median salary compared to other departments. Okay, so and the second is you can say IT, but and these the top bars are like outliers, and if you see, majorly all the salaries are lying in this box, but the remaining 25% quadrant is basically telling us these are the outliers. So if I say sales has the highest outlier, because the top salary is very far from the normal range salary. So we see HR has the highest median salaries, IT has the lowest and the most consistent salaries, while marketing, why? Because uh, IT doesn't have IT's max salary is the lowest among the others, and marketing and finance have the widest salary spread. Okay, so marketing salary spread is too much. Similarly for sales, the mark is again same, and for the finance. Okay, let's try to do a multivariate analysis where I want to see what is the distribution of age and salary versus department. Okay, so if you see for every department how is the age and salary distributed. So for finance department I see average age is 40, for IT average age is 33, HR is 42, sales is 39. Similarly finance is also 39. Age can't be have, we can't consider age. um, I mean here it is showing as mean, but we should not consider mean. Instead we should use median. Okay, so median, because you can't have age in decimals, so that is the reason. So sometimes you need to understand when to use median, when to use mean, mode, like that. Okay, so this will clearly help you that in IT I see median salary is 80,000, whereas in HR median salary is 83,000, which is the highest. Okay, then marketing is 76,000. So like this, let's perform some correlation analysis between uh, the data, and it will generate for only numeric columns for now. So when I'm running this, what does it say? There is no correlation between age and salary because the correlation heat map shows 0.10 for age and salary. That means, see, in a correlation, it scales between 0 to 1. So if it is towards more, if your correlation number is towards 1, that means it is highly correlated. But if it's towards 0, that means there is no relationship, which we already saw in the scatter plot. Okay, now let's come to missing values. Now for missing values, it's very much interesting, because for missing values we can't simply replace mean everywhere. Okay, so a lot of people say we should use mean. I don't agree 100% there. We, for age can't be in decimals. You can't say, oh Mr. Jack, you are 13.5 years. No, you can't. You have either Mr. Jack is either 13 years or 14 years. He can't be 13.5 years. Okay, so and salary can have even salary. Okay, ideally you can't have salary in decimals. Everybody gets a salary in full round numbers. So ideally, for personally, I would prefer median instead of mean. Okay. So this is the way I have tried to fill the missing values with medians. Okay. Especially for agent salary, because they are numbers. Now when it comes to a categorical variable, you have to be very much diligent about it, because it's important to understand uh, what will you fill with the categorical. So in this case I'm suggesting we should use the most frequent department. So I'll say most frequent department means the highest number of employees are in which department. In, as we saw, highest number of employees are in HR. So here it will take HR as the missing value. Okay, because I'm using mode means the most frequent one, the which department is having the highest number of employees, it will fill with the same. Because what do we say? Okay, in general, if you don't know which this employee belongs to which department, let's put him in the HR. Okay, so now let's check how many missing values are there. So since I didn't run this, it's 6 missing values in department. Let's run this. Oh, so there are no missing values in department now. Okay, so now it is filled with HR. So I hope you are able to understand how you can perform exploratory data analysis on a single data set with a very small number of features, that is two. But when it comes to higher number of features, I may come up with the next video. I hope you are liking this video, and if you want me to generate similar video, please let me know. This is once again signing off. I'm Vaishali Mehta. Thank you so much.